Hello and welcome to this introductory video on waves. In this video we're just going to take a very quick look at what waves are, what they fundamentally do really, and how they go about doing that. So if you've ever been to a beach or a pool, then you've seen waves in water. You know that there is some sort of transmission of something as the wave moves along at the surface of the water, and there's a little bit of bobbing up and down as that wave type moves along. So what is really going on there? And the single most important feature of waves is that they actually carry either energy or information, or really both of those things. So in the case of that water wave, you know that as that wave is moving along, it definitely has energy. You've felt it if you've been in the water, push you around. So there's some energy there in order to be able to do the work of pushing you around. And they also obviously carry the information. There's a part which is still, there's a part which is waving, and as that wave moves along, it's letting the rest of the water know that it needs to wave, okay, and go bobbing up and down and continue to carry that energy forward. So we'll look at this in more detail in different applications, but that's the basic idea. You're carrying energy or information, or really both of those things in your wave. Now, how do you really go about doing that? So there are two types of waves basically split on exactly how particles are moving with respect to how the energy is flowing in that sort of wave case. So in the first case, we have what we call transverse waves. So to make sense of what a transverse wave is, here is what we're going to do. We're going to look at this particles all along here. These colorful dots are our particles. We're going to have a wave which is going to propagate over from the left, coming all the way over to the right. And as we do that, we're going to take a look at how each particle moves. So you can see they move down and then back up along any particular line, just going up and down, staying along that wave. All right. So those lines, those dashed lines along the x-axis indicate the motion of our particle. If you pick any particular particle, it always stays at the same x. It's just moving down and then back up, a little bit slow, and then down, and staying right there with that motion. So even though the wave is moving or propagating to the right, the particles themselves are not making any progress. And the key thing here is that this thing was propagating to the right, but the particles were moving up and down. And that is the key defining property of this transverse wave. Transverse is really just another word for perpendicular. So you've got the particles moving perpendicular to that direction of propagation. Okay, there's several examples of these. The wave on any sort of a string, when you normally just jiggle the end up and down, that is going to be a nice transverse wave. And the one that I've been talking about already, as I said, when the wave in the water comes along, the things on the water actually end up bobbing up and down. They don't really get pushed to the side. Okay. On the other hand, we've got longitudinal waves. Longitudinal waves move in different ways. Here's the picture. The wave is now coming along to the right, and the little particles now, if you watch them, what do? Well, they jiggle a little bit to the left, and they jiggle a little bit to the right. That's all that they do. There's a motion along x, and the particles are jiggling back and forth along x. And you see sometimes they get really dense, and sometimes they get really spread apart. And that's sort of what this wave is representing. It's representing where the regions are, so the peaks of this wave are where the particles get over-dense and sort of under-dense or rarefied. Okay. So that is the key thing here, is unlike the transverse wave, now our particles are displacing along that same direction of motion of the wave. So the wave is propagating along x, the particles are oscillating along x. Notice that in both of these cases, in the transverse it was sort of obvious, they were going up and down, so they were definitely not making any progress along x. But even here in this longitudinal case, even though they are now moving along the direction of propagation, all they ever did was jiggle a little bit to the left, a little bit to the right, and they were just sort of staying in the same place. So the particles themselves are not really moving along with the wave. Only that energy or information is being carried along. All right, and so an example of a longitudinal wave is exactly me standing here speaking, because sound waves do this. They compress the air and then they rarefy the air, and that then creates oscillations in your eardrum so that you can hear them, for instance.